Welcome to ASU's University Academic Success Programs. This video will cover the topic Determinants. Our first example will be finding the determinant of matrix A. There are multiple ways of writing the determinant of a matrix. Two examples of writing the determinant is vertical line A, vertical line, and DET parentheses A parentheses.
How would we find the determinant of A?
Before we find the determinant of A, we must first know how to find the determinant. We will begin by looking at the determinant of a 2x2 matrix. We look at the determinant as if the matrix is X is equal to first row A, B, second row C, D. When we take the determinant, it will look like determinant of X is equal to A times D minus B times C. We will now look at matrix A. A is equal to first row 3, 8, second row 4, 6. Now we must take the determinant of A. We will write this as vertical line A, vertical line, is equal to vertical line, first row 3, 8, second row 4, 6, vertical line. Now we must take the determinant of A. We will write this as 3 times 6 minus 4 times 8. This can be simplified to vertical line A, vertical line, is equal to 18 minus 32, or negative 14.
Okay, but what do we do if we have a larger matrix?
Great question. Now that we have found the determinant of a 2x2 matrix, we will find the determinant of a 3x3 matrix. We will first look at the example matrix. Row 1, A, B, C. Row 2, D, E, F. Row 3, G, H, I. We find the determinant of this matrix by multiplying A by the determinant of the 2x2 matrix that is not in A's column. Then we do the same for B and C. This will look like A times the determinant of the matrix, row 1, EF, row 2, HI, minus B times the determinant of the matrix, row 1, DF, row 2, GI, plus C times the determinant of the matrix, row 1, DE, row 2, GH. The determinant can also be written as A times parentheses E times I minus F times H parentheses minus B times parentheses D times I minus F times G parentheses plus C times parentheses D times H minus E times G parentheses. Now let's try an example. Our matrix will be B is equal to row 1, 6, 1, 1, row 2, 4, negative 2, 5, row 3, 2, 8, 7. The determinant of B is equal to 6 times the determinant of row 1, negative 2, 5, row 2, 8, 7, minus 1 times the determinant of row 1, 4, 5, row 2, 2, 7, plus 1 times the determinant of row 1, 4, negative 2, row 2, 2, 8. We now take the determinants of the smaller matrices. This would give us the determinant of B is equal to 6 times negative 2 times 7 minus 5 times 8 minus 1 times 4 times 7 minus 5 times 2 plus 1 times 4 times 8 minus negative 2 times 2. Now we continue to simplify. This gives us determinant b is equal to 6 times negative 54 minus 1 times 18 plus 1 times 36. Now our final answer will be determinant of b is equal to negative 306.
Can we use a calculator to solve this problem?
Yes, we can. To solve the determinant of a matrix on our calculator, we must first insert our matrix. Then we use the determinant function, which will state det parentheses. Now we select matrix A. This will give us det parentheses bracket A bracket parentheses. We hit enter. This will give us the solution to matrix A.
Wow, that's awesome. Just to make sure I know how to do it by hand, for a 2x2 matrix, we take the number in the A1 1 position and multiply it by the A2 2 number. Then we subtract the product of A1 2 and A2 1. To find the determinant of a larger matrix, such as a 3x3 or a 4x4, we must start by multiplying A1 1 by the determinant of the next matrix that is formed by all columns and rows that do not contain A1 1. We continue to do this for every value in the first row while alternating between positive and negative values. If the ending result is the first row and 2x2 determinants, then take the final answer. If not, continue taking the determinant until you're left with only 2x2 determinants. Also, we can never take the determinant of a non-square matrix.
Great, all you need is a bit more practice.